Hi, my name is Shumpaka Amalin binti Mahaze. I will talk about the introduction and objective of this project. Filtering a time series is removing spectral power at a certain point. It also involves the full or partial suppression of one or more aspects of the signal. Digital filtering is not only a smoothing or averaging operation but also as any processing of the input signal. Generally, there are three basic filter transfer functions, which are band pass filter, low pass filter, and high pass filter. A band pass filter removes both high and low frequency, retaining only frequency in the center of the spectrum. A high pass filter keeps higher frequency while filtering out lower frequency. Meanwhile, a low pass filter does the reverse. Digital filters usually apply in time series analysis and digital signal processing, which is DSP. Filters in DSP application must be highly efficient and they must typically be generative since it relies only on prior data samples to do the filtering in real time. This project will focus on fundamental MATLAB-based filtering techniques for time series. There are three objectives for this project. The first one is to develop the understanding and capability in generating and plotting spectrum of signal in MATLAB software. The second one is to achieve the capability in calculating output signal of the filter system. The last one is to determine which filter is suitable to use in presenting the spectrum of the signal.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hani Amizah Helmi bin Bunaim and my metric number CE1900309. So I will present about the methodology of our project. Alright, so for our methodology, the methodology describes on how the project is organized and step flow to complete this project assignment. This project of developing with filling using MATLAB software to plot the signal and determine its spectrum based on digital signal generated has been given. There are some steps in order to develop this project. The steps are in the flowchart. Alright, this is our flowchart. So first step is we start and then we analyze equation generated coding after coding and design filter. Then we simulate and test the coding. Then after we get the result, we complete the simulation. And if anything wrong or troubleshoot, we will restart and do again the simulation and test and the coding. Then we present explanation, then stop. Alright, next, band pass filter. So for our project, we use the band pass filter. A band pass filter or band pass filter is a device that passes frequencies within a certain range and rejects frequencies outside that range. It's an electronic device or circuit that allows signal between two specific frequencies to pass, but that discriminates against signal at other frequencies. Then band pass filter are used primarily in wireless transmitter and receiver. Okay, next. Alright, so this is a advantage of band pass filter. The first one is when the filters are used in conjunction with switch, it's offer low insertion loss and performance increase. Second, passive filter are easier to design. And third, available in portable size. And lastly, as active component in the circuit provide application, active filters has power gain. Alright, thank you. That's all for me.
Okay. Good day, Dr. Ahmad. My name is Nityan Raja. My matrix number is CE19003. And let me start my presentation, which is a continuation of methodology. We will start with the software used for this project, which is MATLAB. MATLAB software has been used as the main platform in order to generate and analyze the discrete signals. Signals from a variety of data sources can be simulated using MATLAB and signal processing products. It is important to note that digital signal processing systems are frequently constructed in MATLAB and then implemented in C language on the target hardware. This is due to the fact that this software makes it easier to create and test algorithms. For plotting scientific graphs, MATLAB includes a wide range of constructions and suitable for use in report and other applications, either from raw or calculated data. The advantage of this software is that it is suitable for a variety of computer operating systems. Aside from calculation, MATLAB has a variety of features for displaying data in the form of various graphical plots. Okay, let's move on to the next slide. I will explain about FFT and DFT. The fast Fourier transform is an implementation of the DFT which produces almost the same results as the DFT, but it is incredibly more efficient and much faster, which often reduces the computation time significantly. It is just a computational algorithm used for fast and efficient computation of the DFT. The discrete Fourier transform (DFT) is one of the most important tools in digital signal processing that calculates the spectrum of a finite duration signal. It is very common to encode the information in the sinusoid that forms a signal. However, in some applications, the shape of a time domain waveform is not applicable for signals, in which case signal frequency content become very useful in ways other than as a digital signal. So the representation of a digital signal in terms of its frequency component in a frequency domain is very important. The algorithm that transforms the time domain signals to the frequency domain components is known as the discrete Fourier transform or DFT. So this is the workflow of question 1, which we generate signal using the given data in Microsoft Excel. We write coding, then we get the initial digital signal, then we analyze the data from the MATLAB. So this is the workflow for question 2. Again, we use the signal from question 1, and then we generate filtered signal. So we write and edit coding, and we process the filter design. Then we get the filtered digital signal. Then we analyze the data from MATLAB. So this is the workflow for question 3. So we need to generate spectrum for filter signal from question 2. So we write and edit coding using MATLAB. Then we process and determine the spectrum for filter signal. Then we get the spectrum for question 3. And then we obtain and analyze the data from MATLAB. So this is the workflow for question 4. So we compare the signal before and after filtering, and we decide if the signal meet the requirement for each type of filter. And then we check the signal meet requirement. So we choose the filter type and analyze the data from MATLAB. So that's all from me now. So I will pass this presentation to my teammate. Thank you.
Okay, hi, Assalamualaikum. My name is Ahmad Farid. For the result and analysis question 1, okay. So for the question 1, we use the value from Microsoft Excel that we get. This value from Microsoft Excel, and after we simulate, we got the signal. This signal for question 1. Okay, for the signal, our data, and before we apply filter is unsteady energy. Okay, for the spectrum, we got this figure after we apply the filter. Okay, for the question 2,
Okay, my name is Naib Rizwan bin Zaid. So for question 2, we have to apply filter to the signal. So we put the filter through this MATLAB. We coding and using this by the value of x, this one. And after we simulate, we get the signal, which is figure 3. This is the signal after we filter the initial signal, and figure 4 is our spectrum after we filter the previous signal. So for question 3, we can see the signal after filter. Words. For a signal after filter, it look like this. This is a signal after we apply the filter, and for the spectrum, we get this is spectrum of our signal after we apply the filter, and we can see the filter prevent undesired frequencies from passing through. In this image, the filter is applied to the both the left and the right sides at 5 Hz. Okay, next for question 4.
Okay, for the question 4, we can see here the spectrum before filter and spectrum after we apply the filter. So this is an example before we filter, and the figure is after we apply the filter. Okay. So at this moment, we can observe that the frequency has been filtered both sides. The bandpass filter lets you listen to signal within a specific range of the frequencies while blocking signal at other frequencies. So for the conclusion is by seeing that filter, we stabilize the spectrum. We can tell that at 30 Hz, the left and right side will be filtered.
Okay, that's all from us.
Thank you.
As the outcome, the understanding and capability in generating and plotting spectrum of signal in MATLAB software be able to develop since this project has been carried out in phases through gradual steps in subjects involved with digital signal processing. The capability in calculating output signal of the filter system be able to achieve since the simulation result need to be compared in order to get the precise result. Bandpass filter has been used for the filter response since it allows signals within a selected range of frequency to be decoded and preventing signal at unwanted frequencies from getting through based on the result of the project. Therefore, digital filtering is used extensively and increasingly attractive because of the ever-increasing demand for data communication. In conclusion, an applicant must acquire the fundamentals of digital signal processing in able to allocate their skills in this field to professional progress. That's all. Thank you.